Galaxies appearing in the data that should not exist. Not unusual in shape, Cow, in when they existed.
The Standard Model predicts with mathematical precision how large a galaxy can be at any given time after the Big Bang. Webb's galaxies violated that prediction.
Several cosmologists published papers. The Standard Model requires revision. Not one said what it should be revised to.
The telescope designed to confirm the earliest chapters of cosmic history is producing data that challenges the model those chapters are written in.
Either the physics of early galaxy formation is fundamentally wrong, Rod, or the timeline itself is wrong. Neither answer is comfortable.
The response from the scientific community? Systematic silence rather than systematic engagement.
The James Webb Space Telescope, launched December 25, 2021, reached full science operations in July 2022.
Positioned 1.5 million kilometers from Earth.
Within months of Webb beginning science operations Durate, the framework began producing results it was not designed to accommodate. In July 2022, a team led by Ivo Labbé identified 6 massive galaxies. Their stellar masses? 10 billion to 100 billion solar masses each. The model allows a maximum of 1 billion at that epoch.
10 to 100 times more massive than the model allows. Published in Nature, February 2023.
The official response: the photometric redshifts might be incorrect. The galaxies might be closer than they appear. The masses might be overestimated. Subsequent spectroscopic confirmation: redshifts consistent with the photometric estimates. The galaxies were real. The problem did not resolve. The Labbé paper was not isolated. In the 2 years following, multiple independent teams found similar populations. The problem is not one galaxy. It is a statistical excess. The SEER survey found evidence for a galaxy population at redshift greater than 10 Bro, approximately 10 times higher density than Lambda-CDM predicts.
10 times the predicted density. Across multiple independent surveys, a systematic excess that persists after every known correction is applied.
Some researchers propose the stellar mass estimates are systematically too high.
The luminosity bias explanation accounts for some but not all of the excess. A statistically significant residual remains after all known corrections.
When researchers cross-referenced the excess with the predicted reionization history Caperi, they found something that had been there the entire time.
One of the best constrained epochs in standard cosmology. The Planck satellite established its timeline. Webb is now challenging it.
If the Webb galaxy populations are real, start to pay.
2 well-constrained datasets. 2 highly precise instruments. Inconsistent with each other within the same theoretical framework.
There is no published revision of Lambda-CDM that successfully incorporates the Webb galaxy excess while remaining consistent with the Planck reionization constraints. None.
The framework has been noted to require revision. The revision does not yet exist.
What came next changed everything, and almost nobody reported it.
In 2023, Webb spectroscopy showed that several massive early galaxies contain heavy elements: carbon, oxygen, silicon.
Heavy elements require multiple generations of stellar evolution to produce. Stars live, fuse hydrogen, die in supernova explosion.
For multiple stellar generations to have completed by redshift 7 period, star formation must have been earlier, proceeded faster. These explanations require the early universe to have contained stellar populations so different from anything observed.
3 separate anomalies, 3 separate types of observation, all inconsistent with the same theoretical framework. If the Webb anomalies are real Chi, either the physics of early structure formation is fundamentally different from Lambda-CDM, the physics of early galaxy formation is wrong, Gad, or the timeline itself is wrong. These are not equivalent revisions. They require completely different responses. The Webb telescope continues to operate. Its data continues to accumulate. The anomalies continue to be confirmed. The revision continues to not exist.
The Roman Space Telescope, scheduled for the late 2020s, will extend the survey to larger samples, either confirming or resolving the Webb anomalies at statistical precision.
The Euclid satellite, launched 2023. Wide field survey. The large-scale statistical context needed to determine
what may be permanently unknowable within current instruments. The true stellar masses of galaxies at red than 10.
The problem is partially self-referential, using the Standard Model to estimate masses of galaxies that challenge the Standard Model. You now know that the telescope designed to confirm the earliest chapters of cosmic history has instead. The incompatibility has been noted. The revision has not been published. These two facts existing simultaneously in
The telescope is collecting light right now. The galaxies are real. The anomalies are real. The revision has not arrived.
Lambda-CDM, tested against every observation for 50 years, now producing systematic inconsistencies with two of the most precise instruments ever built.
50 years of confirmation, 2 years of Webb. The anomalies are systematic, not single outliers, not calibration errors, systematic.
Lambda-CDM may be wrong about how quickly galaxies form, or the redshifts may be systematically biased.
3 possible explanations, each accounting for some of the excess, none accounting for all of it.
The current state of the evidence does not yet distinguish between these two possibilities. The honest answer is that no one knows which revision is required.
The telescope is collecting right now, light from when the universe was a few 100 million years old.
Thousands of physicists trained in Lambda-CDM, struggling to explain data within a framework it is inconsistent with.
Papers with careful language and hedged conclusions, quietly in the cosmology literature, describing data as requiring something that does not yet exist.
A new model of how the universe built its first structures. That model does not yet exist. The data requiring it does.
They were there before Webb found them. They have been there for over 13 billion years.
Massive, structured, chemically mature, at a time when only small, primitive, chemically simple galaxies should exist. The galaxy mass excess, real after spectroscopic confirmation. The Planck Webb inconsistency, real across
3 pressure points on the same framework, each at a different component. No revision yet proposed that addresses all 3 simultaneously.
The standard model requires revision. That is in the published literature. What the revision is 5, that is not.
The telescope was designed to confirm the earliest chapters of cosmic history. It is instead producing data that challenges the model those chapters are written in.
Incompatible with the framework. The incompatibility has been noted. The revision has not been published. Both of these facts are in the literature, simultaneously.
The Planck measurement of the cosmic microwave background, the most precise measurement of the early universe.
The proposed modifications to Lambda-CDM, what they would mean for the age and composition of the universe. That investigation has already begun.
The challenge is not to whether the Big Bang happened. It is to whether the model of what happened in the first billion years is correct.
The first billion years of cosmic history. The physics that produced everything, if it is different from the foundations.
If the first galaxies are wrong in the model predicts.
The cosmology community is not silent because the anomalies are unimportant. It is silent because the revision required is too large to make quietly. Papers noting the anomaly, numerous. Papers proposing the complete revision, none. The community acknowledges the problem. The solution does not exist yet. You now know what Webb found in its first 2 years, what the cosmology community has described it as, what they have not yet described as its replacement. The complete picture. Real data, real anomalies. The galaxy mass excess is real. The reionization inconsistency is real. The heavy element abundances are real. The revision is absent, all simultaneously true.
The 6 galaxies, spectroscopically confirmed, unchanged by the controversy they generated, present for over 13 billion years.
The Webb telescope continues to operate. The Roman Space Telescope will extend the survey in the late 2020s.
3 instruments, all measuring the same early universe. The data accumulating.
The light from these galaxies has been traveling for over 13 billion years. It arrived at a mirror. The data it produced does not fit the model built to receive it.
13 billion years of travel, arriving at a mirror in 2022. Data produced, model challenged.
The proposed modifications to Lambda-CDM, what they would mean for the age and composition of the universe. That investigation has already begun. Stay close.
The early universe as Webb found it, more structured, more massive, more chemically mature than the universe the model predicted would be there.
The galaxy mass excess, the Planck Webb inconsistency, the heavy element abundance. 3 anomalies, 1 framework under pressure, no published revision.
50 years of confirmation, 2 years of Webb.
a systematic challenge that no published yet addresses. The galaxies were there before Webb found them. They have been there for over 13 billion years, unchanged by the controversy they have generated.
The galaxies exist. The model struggles to account for them. The galaxies do not care about the model. They have been there since the universe was young.
Right now, the light from galaxies that should not be as massive as they are is arriving at Webb's mirror. The data it will produce, the challenge it will add.
The telescope is collecting right now. The anomalies are in the data. The revision is not yet in the literature.
It was doing this before the first paper describing the problem was published. It is doing it now. It will be doing it when the next data set arrives.
The standard model of the first billion years. Under systematic pressure from the most precise telescope ever built, the pressure is real, the revision is absent.
What did James Webb find that contradicts the Big Bang? Massive galaxies where there should be primitive composition.
The model predicted this. Webb found this. The gap between them is real. No published framework yet explains it.
The proposed modifications to Lambda-CDM what they would mean for the age and composition of the universe tau, that investigation has already begun.